In this video we're going to talk about inverting functions. Now when you talk about the inverse of a function, what that means is basically a function goes one direction and its inverse goes the opposite direction. So let me show you something that makes it a little more clear. Let's say that we have some f of x such that f of 3 is 5. Well, then if f of x is a one-to-one function, and we're going to define one-to-one a little bit later on, then we can find an inverse function such that f inverse of 5 equals 3. Basically, you're just switching them out. Instead of going from 3 to 5, you're going from 5 to 3. So let's go to before I go on to the example, I do want to say that this -1 is a notational issue. It does not mean 1 over f of x. That's something that's pretty important to understand. It's just notation. When we actually invert the functions, we'll see exactly how we find them. So let's go on to let's just show a brief practical example. Let's say we're converting miles per hour to kilometers per hour. So we'd have f of 55 miles per hour. So f of 55 miles per hour, close parentheses, is equal to 88 kilometers per hour. So this is our original function. So this is, I didn't mean to scroll down. So this is the original function. But then we want to find, what if we want to convert the other way around? So this is good if we have miles per hour and we want to convert to kilometers per hour. But what if we have kilometers per hour and we want to find miles per hour? So then we'd have f of -1, f inverse of 88 kilometers per hour. So f of 88 kilometers per hour is going to map to 55 miles per hour. So instead of going in the direction from miles per hour to kilometers per hour, we're going in the opposite direction, kilometers per hour to miles per hour. So that's what the use of this is. I mean, it's often very important to be able to go in the opposite direction of the original function. But before we can invert a function must be one-to-one before we can take its inverse. Or we can find, I should say. So, to explain this concept of one-to-one, what it means for a function to be one-to-one, you can think of a function as a set of ordered pairs. So let's say if f of x is equal to x plus 2. So that means that f of 3 is equal to 5. And it also means that f of 4 is equal to 6. And just for the sake of completion, we'll say f of 5, not for completion, because, whoops, what did I do here? Oh, I forgot to. F of 5 is equal to 7. Okay, so that means that f of 3 is going to be 5, f of 4 is equal to 6, and f of 5 is equal to 7. Well, we can think of this as a set of ordered pairs. So we can think of it as 3, 5. We can think of it as a set, too. 3, 5, 4, 6, and 5, 7. I know that seems a little bit strange, but it's actually, all it's doing is it's just another way of writing it out. Now this is incomplete, obviously, because there are going to be, if we had the complete relation in this form, it would be infinitely long, because you can put anything in for x. But this is still like a partial, more or less, representation of this function. A function that's one-to-one would not ever have the same y value more than once. So this is an example of a function that is one-to-one, because you have 5. Do you ever have any other 5s in the y values? No. I mean, you have a 5 here, but that's an x value. Do you have any other 6s in the y values? No. Do you ever have any other 7s in the y value? No. So this is a one-to-one function because no y value ever repeats itself. And I'm going to go ahead and write that down. I'm going to clear this off. So a function that's one-to-one would not ever have the same y value more than once. So let's look at a couple examples. Let's if we're thinking of this in terms of sets, and it is important to think of it in terms of sets sometimes. Let's say we have 3, 2, 4, 7, 6, 8, 10, 2. So this is an ordered pair. I'm sorry, this is a set of ordered pairs. So is this function one-to-one? No, it's not, because we have this 2 appearing more than once. This 2 is in the y value twice, so that means it's not a one-to-one function. So this is not one-to-one. This is I mean, you can kind of imagine why this is the shorthand for one-to-one often. So let's do another example. We have s equals -1, 4, 0, 5. Oops, I forgot the first parentheses. And 2, 8, and 5, 9. Okay, so is this... Oops, I forgot to close the set now. Is this going to be one-to-one? Yes, it is, because, see, there's a 4 here, there's no other 4s. There's a 5 here, there's no other 5s. There's an 8 here, there's no other 8s. There's a 9 here. We've already eliminated everything else, so there's no other 9. So this is an example of something that is one-to-one. So these are this is the ordered pair way of thinking of it, and it is pretty important to be able to recognize this, because the point of a one-to-one function is that if you know that the point of a one-to-one function is that for every value y, wow, that's not, so let's say you have f of 3 equals 5, and we also know that we're talking about f of a, and a is an unknown, equals 5. Well, since no x value ever repeats itself, since no y value, ever repeats itself, there's not going to be this. If f is one-to-one, then this can never be something else. I'm trying to think of a way to say this. This 5 can only be associated with one number, so that means we know that a must equal 3. That's the significance of one-to-one. Okay, so how do we recognize this on a graph? We see it here if we list out the elements, but obviously we can't list out the elements for every single what's what I'm looking for every single function that we have to see if it's one-to-one, because there's an infinite number of elements, we can't list them out. So we have the horizontal line test. The horizontal line test, remember the vertical line test, will just tell us if something is a function. That's all it tells us, whether or not something is a function. So let's see if I can. Here is a graph of x squared. F of x equals x squared. So we know that this is a function because no matter what vertical line we draw through it, it will always cross exactly one time. So the vertical line test tells us that something is a function. But then there's also the horizontal line test. And I'll go ahead and write out the horizontal line test. It's very, very similar, of course. If any horizontal, not horizontal, if any horizontal line passes through a curve more than once, it is not one-to-one. So if we have a graph, if any horizontal line passes through a curve more than once, it is not one-to-one. So just like if a vertical line passes through more than once, it's not a function. If a horizontal line passes through more than once, it's not a one-to-one function. So like this, for example, this is x squared. This is not a one-to-one function because this passes through this vertical line passes through this graph more than once. So it's not a one-to-one function. On the other hand, let's talk about x cubed. So any horizontal line is not going to pass through more than once. Not even here. I mean, it may look like it stays on the line for a while, but it's not. It's only passing through once there. So this is a one-to-one function. So if it is one-to-one, then we can invert it. So, but no, let's go ahead and keep going. So to find the inverse of a function, no, let's go ahead and I'm going to make this a separate video just to make it a little bit more accessible. So that way the main part of the examples are in a separate video, so you can go to that separately if you want to. Okay, so I'll see you in the next video.